Alrighty, so here we have a few examples where I give you a rectangular equation and we are going to create the parametric equations given what t equals, or kind of one parametric equation, essentially. So if you think about it, all of these graphs are actually going to look pretty much identical because we're going from this guy, y equals x squared minus 4, which if I just graph to start off, it's going to be a parabola with vertex at 0, -4. And I can even throw some points in here, right? We'll have zeros at positive and -2. But that would just be our rectangular graph. So we want to throw in the orientation for these. And I threw in a new vocab word here, which is the speed, which is really just us writing in the t-values. To show kind of the rate at which t increases, which is speed. So it really shows how, and I'm going to put in quotes, how quickly t changes. So to do this, our first one is really straightforward. We have t equals x, and essentially we would just substitute this in to our original equation. We have y equals x squared minus 4. All right, well, we're just going to sub t in for x, since that's what it equals. So our parametric equations, we're going to have y equals t squared minus 4, and x is exactly what we have up there. But we will use these now to find out our speed, the values on the graph. So I like to use the x equation, and right when x is 0, that'll be t is 0. When x is 1, t is 1. So the speed, right, when x is 2, t is 2, can come, or the speed will give us the orientation, right, what direction our graph goes as t increases. So when things get a little bit more complicated here, the first thing I like to do is figure out for the second one what x equals. So I'm going to solve for x. So I'll get t minus 1 over 4. And then that's going to go back into our x equals equation, or sorry, our y equals equation to get what y equals. So I'm going to say sub into rectangular. So y equals x squared is t minus 1 over 4 squared minus 4. Now, just to make this a little bit more friendly, maybe, right? We're used to seeing kind of this form. This would be 1/16 t minus 1 squared. But there, as long as you have x equals, actually I switched this to an x, that should be a y. As long as you have a y equals equation and an x equals equation, it doesn't really matter what form it's in, you just want to isolate x and y. But it is good to kind of, if you need to think about like domain of x, for example. Usually if it's a parabola or an ellipse or something, it wouldn't be an ellipse, just something that we're used to finding the domain for, there might be a good form you like it in. So that's those. Our rectangular form is going to look exactly the same. So it's still just going to, typing by accident, still just going to fill these in. And let's find our orientation. So for this one, like I want to find, if I throw a 0 in here, right, for x, and then I solve to find out what t is, I'll do it over here. 0 equals t minus 1 over 4. It looks like t would be 1 in that situation. We don't need to show all this. I'm going to erase that. And let's think about here. When x is 1, it looks like t would be 4 plus 1. I think it would be a 5. That's it. And just 2 points is enough for us to see orientation. So I know that my graph, the orientation will be from left to right here. All right, so try out that last example, writing your 2 parametric equations and writing in the t values and the orientation on your graph.